Hi, I'm Wilf, and today we're going to be learning about fusion. Now, I wonder, how does the sun make light? Now, that is a very, very interesting question. Now, it's very fun to answer too. So you can see, I've got these balls. And these are going to represent the stuff inside the sun, which is plasma. There's plasma in the sun, and this is going to be our model of plasma. So the blue ones are protons, and the red ones are neutrons. Protons and neutrons, yes. And they are and there's also between everyone, like these are joined up. And everyone has little electrons. Like there's if this was a proton and that was a neutron, then an electron would be like the size of a grain of sand or something. They're unbelievably small. So we are going to start with the proton as hydrogen. There's our hydrogen over here. Here it is. I'm just going to pop you there. And it's going to collide with another hydrogen. Hydrogen 2 over here. And when they collide, now you may think they create two protons and two electrons. Now that's wrong. They don't. They create a proton and a neutron and an electron. Because a proton and an electron make a neutron. Yeah, we've got this, and this is called hydrogen 2. And then this hydrogen 2 is going to collide with another proton, and it will make helium 3, which has 2 electrons. And that helium 3, hold on, let me just get some more balls. That helium 3 will collide with another helium 3, which makes, finally, last but not least, helium and 2 extra hydrogens. Now you're thinking, well then, why do people tell me that the sun's going to run out of fuel one day? Now you may not realise this, but when we have the hydrogen 2, it collides with another hydrogen, which means it takes 3 hydrogens and then it gives 2 out. So eventually the sun will die and turn into a red giant, and lots of stuff we're not going to talk about in this video. And now, after we've got this, hold on, let me get that back. After we've got this helium, we're going to go bigger elements, much bigger. So hold your horses, because we're going to, hold on, let me get, and then in a bigger star than our sun, like, I don't know, just a bigger one, imagine a bigger star than our sun. And in their core, the 2 heliums would collide, making a beryllium. Now this is getting a bit heavy. Now most of these elements are not stable except for helium. So they will collapse if you found them here. Well, they would bond with something. And the helium wouldn't. But because there's so much gravity concentrated and pushing into that point, then they're allowed to form because of the laws of physics. And yes, and then this beryllium collides with another, oh, how many are we going to have of these? Another helium, which makes something life on Earth always needs, carbon. But you would die if you went anywhere near this carbon, because it's in a molten state. It's like all the protons and neutrons aren't really attached. They're just like moving about in the same point. So the carbon gets hit by a helium. Which turns it into oxygen. And then the oxygen, hold on, let me get this. Actually, I'm just going to figure out how to get the most. Gets hit by another oxygen and turns into a silicon isotope. Pretending this is another silicon isotope, they collide, making a molten iron. If the star is big enough, then it may even go to nickel or cobalt, or even heavier elements like gold. Like, they're so hot, they're just bubbling about. They're not really atoms. They're just parts of atoms jiggling about. But by the way, there's loads of other chemical reactions going on in the star while all of this is happening. But this is the only one that produces most of the light and energy. It creates energy in the form of photons and gamma rays and X-rays. And it also produces visible light, which is lucky, so we can see, and it's not just blackness everywhere. And that's a lucky thing, isn't it? So yes, I think that's today's video. And comment if you liked the video, or just like, or subscribe if you haven't subscribed. So yeah.